Hello everyone, welcome to course study on solid mechanics. In today's lecture, we are going to discuss the concept of stresses, strain and deformation in determinate shaft of homogeneous cross section. So, first of all, we will discuss what does the homogeneous cross section means. The homogeneous cross section means the shafts are connected in series. So, we will move to the definition of it. When two or more shafts are connected in series and are subjected to the same torque, it can be that particular shafts, it may be of same material but different diameter, then such a system is said to be in series. So in case of shafts in series, we have connected two or more shafts one by one and it is subjected to same torque at its free end. That particular shaft, it may be of same material but of different diameter. So such a system is said to be in series. So in this particular case, we will consider the two concepts. The first one is when shaft is subjected to constant torque at its free end. So this is the figure in which two shafts are connected one by one. This is the shaft 1, this is the shaft 2. Shaft 1 is AB and shaft 2 is BC. So this particular system, this particular figure is subjected to torque T at its free end, and that torque is acting in clockwise direction. So what should be the effect of that particular torque? So on the basis of that, we have two governing equations. The first one is the total torque can be contributed by both the shaft, first shaft and the second shaft. Therefore this total torque will be equal to T1, which is equal to T2. So the effect of total torque can be taken by both the shaft. This is the first equation we have to consider. And the second one is total angle of twist, that is theta, will be the sum of angle of twist in first material and the angle of twist in second material, that is first shaft and second shaft. So total theta will be the theta 1 plus theta 2. So all of you know that what is the value of theta by using torsional formula. By using torsional formula, we have theta is equal to TL upon GJ. So we will apply this particular equation for both the angle of twist. So it will become, total theta will become TL upon GJ of first shaft plus TL upon GJ of second shaft. But as the total torque is contributed by both the shaft, so we have T as a common. So the final equation will be this one. Remember that this is the case for a shaft when it is subjected to torque at its free end. This is the fixed end and this is the free end. Okay, now we will move to the another term when shaft is subjected to torque at each junction. Now in the first case, the torque is subjected to free end only. Now in the second case, the torque is subjected to each and every junction. So for such a system, we will have first shaft, second shaft and third shaft, that is AB, BC and CD. It is fixed at A whereas free at D. Okay, B and C are known as the junction where two shafts of different diameter are meeting to each other. So B and C are the junctions. So what are the condition, what are the equation for such a system? Remember that the torque at D, so this is this one, the torque at D will be the plus minus T1 because the effect will be on CD only. The torque at C will be the sum of T1 plus minus T2, depending upon the sign convention we have taken the plus minus, and the torque at B will be the T1 plus minus T2 plus minus T3. So those are the two conditions we are going to discuss by in the form of numerical. So we have a statement of numerical: a stepped steel shaft subjected to torque T at free end and torque twice T in the opposite direction at the junction of the two sizes. What is the total angle of twist at its free end? If the maximum shear stress in the shaft is limited to 70 meganewton per meter square, assume G is equal to 80 giganewton per meter square. So as given in the numerical, we have a stepped steel shaft. A stepped steel shaft means two shafts are connected in series and is subjected to a torque T at its free end. So this is the free end and it is subjected to torque T in anti-clockwise direction. Also it is subjected to torque twice T at the junction. Now this is the junction B where two or more shafts, where two shafts, not more, actually it's a two shafts of different diameter are meeting at that particular point. Therefore it is known as the junction. From that particular data we have to find out total angle of twist, that is theta, and theta 1 plus theta, it will give you the value of total angle of twist, and the maximum shear stress is 70 meganewton per meter square. So it is limited to 70 meganewton per meter square and the value of G is 80 giganewton per meter square. So remember that while solving the numerical based on this particular concept, first of all we have to draw the free body diagram. To draw the free body diagram, you start from the free end. You always start drawing free body diagram from the free end. So free end is C, and at C a torque is acting in anti-clockwise direction, because for BC, for this particular shaft BC, C will be the far end and B will be the nearer end. So the far end, that is C, is subjected to anti-clockwise torque, therefore will be considered as a positive. Remember that when the far end is subjected to anti-clockwise torque, so we will consider it as a positive, and if the nearer end is subjected to a clockwise torque, then will be considered as a negative. So at C we have a torque acting in anti-clockwise direction, therefore will be positive. So we will isolate BC from the AB. When we will isolate BC from AB, we will have C, it is acting in anti-clockwise direction. C is subjected to torque in anti-clockwise direction. To maintain the equilibrium, you must apply equal and opposite torque at end B. Therefore at C it is subjected to torque in anti-clockwise direction, so B will subjected to torque in clockwise direction. So in this manner you will keep BC, shaft BC in equilibrium. But at B we have the junction, and at the junction we have the value of torque, that is twice T. So what it indicate? It is the resultant of two torque at junction B. This is junction B, okay, and is subjected to torque twice T at its junction. So what it indicates? It's a resultant of two torque. So we know the value of one torque at B, that is T, which is acting in clockwise direction, but we don't know the value of another torque. What is the value of it, and in which sense and in which direction it is acting? So that we have to find out. So how to find out that particular torque? Remember that at B, see over here, at B we have a resultant, that is twice T. It is acting in clockwise direction. So remember the sign convention. At B it is acting in clockwise direction, so will be negative, because we have considered anti-clockwise as a positive and clockwise as a negative. So here it is acting in clockwise direction, so will be considered as a negative. So this is the resultant equal to minus twice T. Now we know the value of one value of that particular resultant at B, that is this torque T. Again it is acting in clockwise direction, therefore will be minus T plus, suppose if I consider I have to find out the another value, that is F. So how to find out the value of F? F will become minus twice T plus T. So our answer will be minus T. So minus sign means at B the another torque is acting in clockwise direction. So remember that at B a torque is acting in clockwise direction. Therefore we have the resultant twice t, so it's a resultant of 2 torque. So for AB, again we have a torque in clockwise direction. To maintain the equilibrium, you apply equal and opposite torque at the end A. So equal and opposite means in anti-clockwise direction. So in this way we will maintain the equilibrium. So as per the data given in the numerical, we have the G is equal to 80 giganewton per meter square. It is Gn per meter square. We have to convert it into mega pascal or mega newton per mm square. Okay, so how to convert it into MPa? So in MPa, this 80 into 10 raised to 9 will be converted into a pascal, and meter square we have to convert into mm square, that is it is 10 raised to 6. So in this manner we have converted G into MPa, 80 into 10 raised to 3 Newton per mm square. Also, the maximum value of shear stress is also given in the numerical, that is 70 mega Newton per meter square. Again that value we have to convert into Newton per mm square, that is MPa. So after converting it into MPa, we have 70 Newton per mm square. So 70 mega Newton per meter square is converted into MPa, that is 70 Newton per mm square. Remember that we have to find out the value of total angle of twist. As per the given in the numerical, we have to find out what is the total angle of twist at its free end. So total angle of twist at its free end will be the summation of theta 1 plus theta 2, that is theta of AB plus theta of BC. So first of all we will calculate the value of theta for BC, then we will calculate the value of theta for AB. So remember that in case of one end fixed and other end free, you always start making free body diagram from the free end. Therefore for length BC we have torque equal to T. This is the free body diagram for BC. What is the value of torque for the BC? It is T as shown in the figure. So torque will be T only. For the same BC, the length is 1.8 meter. So 1.8 meter means 1800 mm. Similarly, the value of J is pi by 32 d raised to 4. So our value of D is 50 mm. Therefore, the value of polar moment of inertia will become pi by 32 50 raised to 4. On solving this, we have J is equal to 613.592 into 10 raised to 3 mm raised to 4. Remember that this is the value of J. Theta 1, it is the angle of twist of C relative to B, because we have applied the torque at its free end. Therefore the angle of twist will be the C relative to B. Therefore by using torsional formula we have theta 1 is equal to TL upon GJ. This concept we have already discussed earlier. So the value of T will remain as it is because it's a value of T from the free body diagram. The value of L is 1800 mm. Value of G, which is already calculated over here, 80 into 10 raised to 3 MPa. Value of J is 613.592 into 10 raised to 3 mm raised to 4. That value we will put into the equation of theta 1. After putting this value into this equation, we will have one equation in term of T, that is 37 into 10 raised to minus 9 into T. So this value of theta 1, it is in term of torque T. Now we will find out the value of theta 2, that is for length AB. For length AB we have torque equal to minus T. For length AB we have torque equal to minus T. Why minus T? Because this is acting in clockwise direction, therefore will be considered as a negative. Therefore torque T will be minus T. L for the same is 1200 meter. J is pi by 34 d raised to 4, so d is 100. So J value is 9.817 into 10 raised to 6 mm raised to 4. So once you know the value of J, L and T, we can easily find out the value of theta 2. So the value of theta 2 will be minus 1.52 into 10 raised to minus 9 into T. This negative means it is a clockwise twist. So as per the sign convention, we have the minus sign. So once you know the value of theta 1 and theta 2, the total angle of twist will be the theta 1 plus theta 2. After putting value of theta 1 and theta 2, we have total twist equal to 35 into 10 raised to minus 9 into T. That value of theta will be in term of torque T. Now we will use torsional formula to find out the value of theta. So we have torsional formula G theta upon L, tau max upon R and T upon J, and all are equal. So we will, as per the given data, we will concentrate on these two terms only, T upon J, which is equal to tau max upon R. Now for which bar we have to consider this particular equation? We have to consider this equation for a smaller diameter of the shaft, because the shaft which has a smaller diameter will be subjected to the greater shear stress. So remember that we are going to apply, because as per the numerical, as per the statement given in the numerical, we have the maximum shear stress in the shaft limited to 70 meganewton per meter square. This is the value of maximum shear stress in the shaft. So the maximum shear stress will be in the shaft which has a smaller diameter. So we have BC as a 50 mm, diameter of BC as a 50 mm and AB as a 100 mm. So we will apply this particular formula for the shaft BC only, because maximum shear stress will be developed into this particular shaft only. So on putting all those values of J, tau and R into this particular equation, we have T is equal to 1.718 into 10 raised to 6 Newton mm. Once you know the value of T from the torsional formula, we will put this value into equation number 3, because for the theta, the T is unknown. On putting this value into this equation, we have theta is equal to 0.06013. 0.06013. It should be in radian. If you require, you can convert it into degree also. We will discuss the another method to find out the total angle of twist. Again we will consider the free body diagram. This is the second method, or method. Okay, the total angle of twist is equal to twist due to T, that is this T, and plus twist due to twice T, which is applied at its junction. Okay, so the twist due to T will be the TL upon GJ plus TL upon GJ of both the shaft. So TL upon GJ of BC plus TL upon GJ of AB. So T will be unknown. L for the BC is 1800, I have converted into mm. G will be 80 into 10 raised to 3 and J is 613, which we have find out for in this equation, 613.59 into 10 raised to 3 plus TL upon GJ of AB. So L of AB is 1200 upon GJ will remain 80 into 10 raised to 3 and J will be 9.81 into 10 raised to 6. Okay, minus, because it is acting in clockwise direction, minus twist due to twice T. So the effect of twice T will be on AB only. The effect of T will be on both AB and BC. The effect of twice T will be on single only, that is AB. Therefore we will consider only one. So minus TL upon GJ of AB. So 1200 into twice T upon G value is 80 into 10 raised to 3 and the J value is 9.817 into 10 raised to 6. On solving this equation we have theta 0.06013 radian. So we can solve this particular numerical by both the manner, by calculating theta 1 and theta 2 individually or by considering this particular equation also. In the next lecture we will again discuss the same numerical, means the numerical based on the same concept. So we will stop here. Thank you.